So I spent a half hour just getting us used to the theory. Now we should be able to blow through all the problems real quickly. Each of the problems gives me a seed function that it wants me to call out. It asks me to find a new function and describe how the function gets shifted from the original function. Problem 2 gives me that lovely absolute value function. Some of the functions that we'll work with are going to be new, but nothing hard. So part A wants me to find the requested function, h of x plus 4. Because the plus 4 is in a parentheses, the plus 4 is going to go inside the absolute value as opposed to under the absolute, as opposed to after the absolute value. So inside parentheses, when you have an absolute value function, the number goes under the absolute value. And when we have this sort of function notation, where the graph is going to shift to the left, plus inside of parentheses, the graph goes left, plus after it goes up. Pluses are either left or up, depending where the plus is. For part B, when I want to describe what this does, I'm going to say it shifts it left 4 units. That's it. No need to graph. Problem 4 calls out the same h of x, which is the absolute value of x. And it wants me in part A to find h of x plus 3. Because that plus 3 is inside the parentheses, when I rewrite it, that plus 3 belongs under the absolute value. And of course, inside parentheses, pluses are left, minuses are right. Let me get lazy now. Instead of saying it shifts left 3 units, I'm just going to say left 3. Sometimes when I'm writing my keys, I just do arrows. I would just say left 3 for my answer to part B. Hey, I'm calling out a new function, and we haven't got to this yet. 6 is calling out the f function, and the f function is x squared. Because the number is in a parentheses in part A for number 6, I need to create a parentheses. Absolute values kind of work as a parentheses. Square roots work as a parentheses. X squared doesn't work as a parentheses. When I go to do part A, because the plus 1 is in a parentheses and the function doesn't have anything that works like a parentheses, absolute values and square root symbols work like parentheses, I need to introduce a parentheses and put that plus 1 in the parentheses. That's one of the new things in this part of the video. Part B, how does it move it? It shifts it left. Pluses inside a parentheses. It doesn't matter what the seed function is. It's going to move the graph left 1 unit. Little harder to see with my calculator when we're working with parabolas than it is absolute values, but it will happen the same way. Question 8a calls out the same function, that f of x equals x squared. It wants me to find f of x plus 4. Because the initial function doesn't have a parentheses, and I need to keep the x and the 4 bound together, I'm going to create a parentheses and put that 4 inside the parentheses. Pluses, with my function notation, inside a parentheses moves the graph left. Calling out the absolute value again for all these problems. Each one of these problems is referring to the absolute value function. For 10a, it wants me to find h of x minus 4. Because the minus is in the parentheses, it needs to go under my absolute values. And minuses are, if it's after the function, it moves it down. If it's in the parentheses, it moves it right. For each of the problems on this page, it's going to move the graph right. So if I want to be wordy, I can say the graph is going to be shifted right 4 units. For question 12a, there's almost too many of these problems. To find the function h of x minus 3, the x minus 3 is going to go under the absolute value sign. And for 12b, minuses inside parentheses move the graph right. So I'm going to say it moves it right 3. New function to work with. Now we're working with the square root function. The square root function is nice because the square root symbol kind of works like a parentheses. It makes it so I don't need to introduce a parentheses in the part A here. For part A, to do g of x minus 1, because the x minus 1 is in the parentheses, the x minus 1 needs to go under the square root symbol. Doesn't matter what the name of the function is, doesn't matter what the function is. If in function notation I have a minus inside a parentheses, that whole graph is going to move to the right 1. Again, this is the bulk of it. Plus inside a parentheses moves the graph left. Minus inside a parentheses in the function notation moves the graph right. Plus outside the parentheses with the function notation, it's up. Minus after the function notation moves it down. That's the bulk of everything. Then we have some reflecting over the x-axis, reflecting over the y-axis, and making it wider or narrower. But the bulk of what we do is moving it left and right. I'm going to skip 15 and 16 because I don't think they're necessary, and move on to 17 and 18. 17 is calling out the x squared, because it gives me f of x. So 17 is calling out f of x equals x squared. A wants me to find f of x plus 3. Because the plus 3 isn't in a parentheses, that plus 3 has to go after the original function that's given. So this is going to be an x squared plus 3 without a parentheses. Part B, when I have a plus after the function notation, it's going to shift the graph up. So if I wanted to say what this does, it's going to shift the graph up 3 units. Absolutely no need to graph. The graph would confirm what I'm writing, but there's no need to do the graphs. Question 20 calls out the square root function. The square root function is square g of x. Part A of 20 wants me to find g of x, and the plus 6 isn't in the parentheses, so the plus 6 goes after the function. Doesn't matter what the function is. If the number is added or subtracted and it's not in the parentheses, it just goes after the function. For part B, it's going to move the graph up 6 units. Pluses after function notation move the graph up. Pluses inside the parentheses move the graph down. Minuses after function notation move the graph down. Let me say this again. Pluses after the function moves it up. Pluses inside the parentheses moves it left. Minuses after the function moves it down. Minuses inside the parentheses moves it right. So, next function, I don't know why I didn't put 21 and 22 on the same page. Let's just do 21. 21 is calling out the absolute value function. For 21a, I'm going to find h of x minus 3. The h of x function is the absolute value function. Because the minus isn't in a parentheses, it goes after the function. And after the function, plus is up, minus is down. So this would take the whole graph and move it down 3 units. Oh, let me just do 24 on this page. 24 is calling out the cube root function. I have not even graphed the cube root function, but I could still answer these questions. So in part A of 24, supposed to find the function k of x minus 9. Because the 9 is not in the parentheses, it goes after the function. Minuses that are after the function move the graph down. Pluses that are after the function move the graph up. So that would be all the answer that I would probably write. If this was a test, I'd probably write that for the part A and that for the part B. Now the combination shifts. 26 calls out h. The h function is the absolute value of x. If I want to do part A of 26, it wants me to find the h of x plus 4 plus 3. Because the plus 4 is inside the parentheses, the plus 4 from this part of the rewriting the function goes under the absolute value. The plus 3, because it's not in, it goes after the absolute value. For part B, the inside the absolute value is going to move the graph left because it's a plus. The after the absolute value is going to move the graph up because it's a plus. So when I go to do part B of 26, this is going to move it left, that's going to move it up. Pluses inside parentheses here are left, minuses are right. After, positive is up, negative is down. If I did the same thing for problem 28, find the function h of x plus 3 minus 5, it's calling out that same absolute value function. That's the best function if you're graphing on your calculator to see. The plus 3 is going to go under the absolute value because it's in a parentheses. The minus 5 is not going to go inside the absolute value. It's going to go after the problem, or after the absolute value. And for 28b, pluses inside parentheses move it left, minuses after the function moves it down. So I'd probably just write left 3 and down 5. This table is worthy of a note card. It's worthy of memorizing. We do this table a bunch, probably in 3 different chapters we do this table. So this is something that will come up again in chapter 5 and chapter 6, maybe chapter 4, I kind of forget. Maybe it's chapter 4 and chapter 6, but it comes up a couple times. 30 calls out the g function. The g function is the square root of x. Part A of 30 wants me, square root of x. Part A of number 30 wants me to find g of x minus 4 plus 3. Because the x minus 4 is inside the parentheses, it goes under the square root symbol. Because the plus 3 is not in the parentheses, it goes after the square root symbol. Minuses inside parentheses move the graph right. Pluses after the function moves the graph up. I'll progressively get lazier and lazier. I don't have to write anything more than that, just so we kind of understand how the graph moves around. 32 calls out that same square root function. For part A, I want to find g of x minus 3 minus 5. The x minus 3 is going to go under the square root symbol because the x minus 3 is in the parentheses. The minus 5 is going to go after. And it's the left-hand side that helps me. Minuses inside the parentheses on the left-hand side moves the graph right. Minuses not in parentheses after the function moves the graph down. So this guy, for part B, the minus inside the parentheses will move the graph right 3. The minus after the parentheses is going to move the graph down 5. I don't know what I did to make like a monsterly 4-hour video out of this, but I plotted points. I get kind of ridiculous. So the next few problems, you see 33, 34, 35, and 36, they all have negatives in front of the function notation. Negatives in front of the function notation, the part B is going to be reflects about the x-axis, or reflects over the x-axis. 34 calls out the g function. The g function is the square root of x. 34a, because the negative precedes the function notation, it has to precede the square root symbol. Part B for all of these is the graph's going to be reflected over the x-axis. It'll turn a graph upside down. 36 is calling out the f function. To do part A, negative times f of x, I just put negative in front of the function without a parentheses. If the negative was inside the parentheses, I'd need a parentheses. But a negative in front of it won't ever cause me to put a parentheses. It's always going to precede the function that's mentioned. The 4 problems on this page all have the negative inside the parentheses, and negatives inside parentheses will reflect the graph over the y-axis. Each one of these, the part B, is going to reflect over the y-axis 4 times. Let's do 37. 37, the k function is the cube root of x. For part A of 37, because the negative is inside the parentheses, it needs to go under the square root or the cube root symbol. For part B, negatives in front of the function flips it over the x-axis, negative inside the parentheses reflects it over the y-axis. For problem 40, it calls out the f function. I'm going to need parentheses here when the original problem doesn't have something that serves as a parentheses, and I'm asked to do something in a parentheses. I need to introduce a parentheses. So for part A of 40, f of negative x, like this, is going to be the quantity negative x squared, and negatives inside parentheses flip the graph over the y-axis. Negatives in front of the function flips the graph upside down over the x-axis. Now some combinations. So, 41 and 42 both call out the f function, which is the x squared function. I need to do a couple things in part A. Part A has a negative in front of the function notation, so I need to lead off with a negative. It has a +4 inside of parentheses. I need to introduce a parentheses to get that +4 inside something that will work as a parentheses. And then the +3 is going to tag along. So the +3 is not it, it's after the square. The minus is preceding the function. The +4 is inside of parentheses. For part B, negatives in front of function notation make it go upside down. It reflects it over the x-axis. With negatives in front of the function, negatives reflected over the x-axis. Inside the parentheses, it reflects it about the y-axis. The plus inside the parentheses is going to move the graph left, and the plus after the function is going to move the graph up. So this graph is going to be reflected over the x-axis. The plus inside the parentheses is going to move it left 4. The plus after the parentheses is going to move it up 3. Again, I'm calling out the x squared function because this is kind of the most common function to work with. So when I have f of x equals x squared, when I do 44 part A, to find the function, I need a negative preceding anything I write, not in a parentheses. I need an x plus 3 in a parentheses for the x plus 3 in the parentheses part, and a minus 5 afterwards. The minus that precedes the function flips it over, makes it go upside down. It will reflect it over the x-axis. A plus inside the parentheses is going to move the graph left. A minus after the parentheses moves the graph down. So this is going to go left 3 and down 5. Oh, calls out the m function. First time for this. The m function is the x cubed function, not a common function to work with. That's why I probably waited all the way to 46 to work with it. For part A, I need a negative preceding whatever I write, not in a parentheses. The x minus 4 needs to be inside a parentheses, and I don't have something that works as a parentheses, like an absolute value or a radical symbol, so I need to create a parentheses for that. And the plus 3 is just going to tag along after. 3 shifts. The minus in front reflects it over the x-axis. The minus inside the parentheses shifts it right, and the plus afterwards moves it up. And if I want to get lazy for part B, I might do something like this. Rather than writing something that's really nice, I might say reflect x, right 4, up 3. That would be adequate. Or I could say it reflects the graph about the x-axis, shifts the graph right 4, and shifts the graph up 3. You don't have to get that wordy for me at all, just so I know that you understand. Calling out the m function again, which is the x cubed function. Doesn't matter which function I use, other than sometimes I need to introduce a parentheses. So first I see a negative out front, I'm going to write that negative. And then I need an x minus 3 inside a parentheses for this function with an exponent of 3 outside, because the original function has the plus the exponent of 3. Minus 5 goes afterwards. Minus in front of the parentheses reflects it over the x-axis. Minus inside the parentheses moves it right. And minus afterwards moves it down. So for part B, it's going to reflect over the x-axis. It's going to move right 3, and it's going to go down 5. That's more like the answers I write, rather than anything that's kind of even close to a sentence. Oh, now we get the making it wider or narrower. So this is calling out the f of x function, which is x squared. That's the most common function to move around. Part A of number 50 wants me to do 4 times f of x. That 4 is just going to precede the function. I'm not going to need any parentheses when I'm multiplying a function by some number. And if you multiply by a number bigger than 1, it's proper to say that it stretches the graph. A lot of times I say it makes it narrower, but when you have square root functions, you can't see the narrower. With absolute values and parabolas, it's easy to say the narrower. So the stretches is technically a better word. So I'm just going to say it's going to stretch the function to be perfectly correct. But this, if you graphed it, it would make it narrower. For x squareds and absolute values, it does make the graph narrower. But for, you can't really make a square root graph narrower, so stretches is probably a better word if I think about it more. 52 is weird. Didn't get to anything like this. It's calling out the same x squared function, and for part A of 52, it's supposed to find negative 4 times f of x. That negative 4 is just going to go in front of the x squared because it's not in a parentheses. This is sneaky. It's going to turn it over and stretch it, or turn it over and make it narrower. This negative out front is going to reflect it over the x-axis. Negative inside a parentheses reflects it over the y-axis. Negative with any number, it doesn't matter, is going to reflect it over the x-axis. And that 4 is going to make it narrower because it's a square. But the proper thing to say from my table, which is more proper than saying narrower, is that it stretches. Again, the negative out front, even though it was attached to a 4, is going to reflect it over the x-axis. The number, if it's in front, is bigger than 1, absolute value-wise, it's going to make it stretched or make it narrower in an absolute value or in a square function. 54 is calling out the h function, which is the absolute value function. Part A wants me to find 1/3 times the absolute value function. I'm just going to put that 1/3 in front of the absolute value. In part B, when you have a number that's in between 0 and 1, it's going to make the graph wider, but the better thing to say is compresses the graph. So here we're just going to say it compresses. It will make it wider, and the wider will be obvious in an x squared function and an absolute value function. Wider would not be obvious with a square root graph. So compresses is probably a better word. 56, calling out that same absolute value function. The part A, I'm just going to put the negative 1/3 in front of the absolute value symbol. That's the finding the requested function that I needed to do. Part B, the negative reflects the graph over the x-axis. And the 1/3, we can say that it compresses it. It really does make it, it looks like it makes it wider for this graph. But it's safer to say compresses and stretching just in case you get into a higher class and you do this. I don't do this in my brief calculus class, but maybe some traditional calculus teachers might do this. All right, just a few more problems, and we're not going to do the whole section. These problems I never put on a test, but they're kind of good to do, just to give you actual practice of sketching graphs. So I give you a graph, and I say this is a graph of f of x, and I ask me in part 58, in question 58, to graph f of x minus 4. So I know to graph f of x minus 4, I need to take the whole graph and I need to shift it to the right 4 units, which means every single point that I have, I need to drag it 4 to the right. Let me start and show you how to do that real quickly. This point right here, I'm going to drag it 1, 2, 3, 4 to the right, make a dot. This point right here, drag it 1, 2, 3, 4 to the right, make a dot. This point, 1, 2, 3, 4 to the right, make a dot. That point, 1, 2, 3, 4 to the right, make a dot. This point, 1, 2, 3, the best I can, 4, and make a dot. So unfortunate color that I just picked. Let me pull out my purple. I just can't find my ruler. The closest thing I have to a ruler is this guy. So this is going to be wretched, but it is what it is. This is my graph of f of x minus 4. I took the whole graph and shifted it to the right. I could have extended this further, but I didn't. And that's all there is for that. These aren't on the test. We're just going to do 2 or 3 more just to give you the idea of how to put this into action graphing-wise. 60 gives me a graph of f of x, and it wants me to graph f of x plus 1. What does that mean to do? That plus is after, so I'm just going to move the graph up 1. I'm going to take every point and drag it up 1. Up 1, up 1, up 1, up 1, and up 1. And then the best I can, graph those. And need something that resembles a ruler. I might have to go out and buy a ruler. So that's perfectly done, well, perfect by my standards done. I took the original graph and shifted up 1 by taking each point that was given to me and moved each point up 1. For 62, I gave you a graph of f of x, and I want to find f of x plus 1 minus 2. The plus in the parentheses is going to move the graph left 1. The minus afterwards is going to move the graph down 2. So what I'm going to do with each point is I'm going to drag it left 1 and down 2, make a new dot, and then connect them all up with the same shape. So start with a little kind of vertexy thing here. Go left 1, down 2, left 1, down 2, left 1, down 2, left 1, down 2, left 1, down 2. I think I've moved them all properly. The Apple Pencil 2 is fantastic. It's my first iPad ever, and it's saving my behind this semester as I'm grading. So that's best I can do. I went left 1, down 2. Surprised how it moved, but it is what it is. I mean, the Alto, I'm not very visual, but I can do mindless things like move every point left 1 and down 2 and connect them with the same shape. One more, let's just do 63 together. 63 wants me to do negative f of x. This is reflecting it over the x-axis. This is going to be weird for this graph. So we're going to do 63 and not 64. And we'll stop the video with this. I don't ask these on the test. Oh, I can't even spell x-axis. How do I reflect it over the x-axis? I change every y. So the point 2, negative 4 is going to change to the point 2, positive 4. You need to get the point on the opposite side of the x-axis with the same x, so you change the y. The point 6, 0 is going to stay 6, 0. The point 8, 2 is going to move to the point 8, negative 2. The point 2, 0 is going to stay right there. The point negative 4, 2 is going to go to the point negative 4, negative 2. So to reflect over the x-axis, you change all the y's. To reflect over the y-axis, I change all the x's. So this is considered reflected over the x-axis, and I think this is where we'll cop out on this video and just end it right here. I kind of like this thing for a ruler. That's considered flipped over the x-axis. Each point gets moved to the opposite side of the x-axis. You have symmetry there to the x-axis. That's enough. We just have one section left of new material, which is word problems. They're not that hard, and I put one of those on the test, and it's the one, if you take me for brief calculus, that you'll see again in the calculus class, and we'll solve it with calculus. So let me stop this and call this done.